Hello, and welcome back to More Math, because you know, everybody needs more math. All right, moving on. So we've been talking about greatest common factor and least common multiple. I wanted to show you something we can kind of do that's kind of cool with that upside down division. You're going to be learning about something called the distributive property. I don't know if you've learned it yet or not, but I want to introduce it right now. And let's see what that is. Well, let's think about distributive. What word do we hear in there? I hear the word distribute, right? Makes me think of Halloween. Any of you guys like to go trick-or-treating? Well, yeah, who doesn't? When you go trick-or-treating, you're hoping that those homes, when you knock on their door, are going to distribute candy to you. In other words, they're going to take a piece of candy from their bucket, and they're going to put one in your bag, and your cousin's bag, and your sister's bag, and maybe even your dog's bag if they came along, right? Everyone gets one. If you go up to the door and there's 4 of you, is the person going to say, you get a candy, you get a candy? You don't. But you get a candy. It doesn't work that way, right? When we distribute, we give one to each person. We're going to do the same thing here in math. You're going to follow what I mean here in just a second. And I got to tell you, this is kind of it's a new topic. It's kind of interesting, but you're going to be like, why are we doing this? Well, I'll tell you, we're learning math right now that lets us do the really cool math later. So we're learning some stuff now that's kind of getting our brains thinking about it. That's going to do bigger math as we get a little older and a little farther along. It's kind of like when you build a house. You really want the front of the house to look good, right, from the street? But that front of the house doesn't look good unless it has a really good foundation. We've got to put in the foundation and the brick and the floor and the sides. We have to build it all up to make it all work. And that's what we're doing right now. We're laying a really good foundation in our math skills. Good job. By the way, I think I said it, or did I? Did you get a piece of paper and a pencil? You don't want to just watch. Boring. Do it with me. And don't forget, you can just hit pause when I ask you to do something, because I'm probably not going to wait long enough because I get excited and I just keep going. So you hit pause and then do it and then start it up again and we'll do it together. Okay? Nice. All right, so we're going to talk about the distributive property. We learned about the greatest common factor. So when we learned the greatest common factor, we learned about upside down division. I'm going to check the numbers I wanted to use. 45 and 60, I remember now. So we are going to find the greatest common factor of 45 and 60. Why are we doing that? Hang on, I'll show you. Really quick though, as a review, can you find the GCF of 45 and 60? We wrote them both down. Good. Then we write that little upside down divisor bar there. Good, good. And now what are we going to do? We're going to pull out those common factors. I like to start with the small prime numbers. I think it makes it easier. You can pull out any factor though. Let's see, can I pull out a 2? No 2. 5 is not an even number. Remember, what's my even numbers? 2, 4, 6, 8. Who do we appreciate? Me. Don't call me a 0. 2, 4, 6, 8, 0. Those are my even numbers. I know 2 comes out. That's not even. Does 3 come out of both of those? Yes, it does. If you're not sure, don't forget to grab that calculator and you put 45 divided by 3 equals. Is it a whole number? No decimals. Then that's a factor. And it is. So I'm going to pull out a 3. And notice I'm going in order. 2, 3. Let's see. 3. 45 divided by 3 is 15. Nice job. 60 divided by 3 is 20. All right. 20, 40, 60. All right. That was a good start. I don't think we're done though. We already know 2 doesn't work because we tried it and it didn't work before, so it's not going to work now. We don't even have to worry about it. But we do need to try 3 again. Does 3 go into 15? Yep. Does 3 go into 20? Nope, no 3. The next prime number is 5. Does 5 go into both of those? And it does. We know any number that ends in a 5 or a 0 is divisible by 5. So we're going to do it again. We're going to divide out the 5. What is 15 divided by 5? It is, of course, 3. Good job. What is 20 divided by 5? It is 4. Do you remember before when we talked about if there's 3, 4, when the numbers are in order, that we know we're done? Okay. So now we've done this, we've set this up. It's like if we're finding the greatest common factor. What is the greatest common factor? Quick review time. The GCF would be what? Yeah, it would be these two numbers here, right? It would be 3 times 5, which is equal to 15. Nice. And what would the LCM be? We just did that in the last video. Remember, we take this big L like this. It would be 3 times 5 times 3 times 4. Oh goodness, I didn't multiply that ahead of time. 3 times 5 is 15. 15 times 3 is 15, 30, 45. Ooh, what's 45 times 4? Well, let's cheat and do it here, right? What's 45 times 4? 4 times 5 is 20. Carry the 2. 4 times 4 is 16. It's 180. So this is going to be equal to 180. So our LCM is 180. All right. But that's not what we're doing right now. So we're back to here again, the magic of production, right? So we're back to here. So now what we're going to do is we are going to write these numbers, 45 and 60, in a different way. We're going to have the same numbers, but it's going to look different. And how are we going to do that? So glad you asked. We're going to take this right here, the GCF, 3 times 5. You know, if you stay with me long enough, you'll find that I do that. I'll say, what is 3 times 5? And I'll write down 3 times, and I'll write the answer instead of the question. My students figure that out really fast, and they're like, oh, you just told us the answer. Yeah, I did. Yeah, that happens. So it's 15. So I'm going to say this 3 times 5, and I'm going to write the 15 right here. Now I'm going to put a parenthesis, and I'm going to just bring down the leftovers just like they are. I'm going to bring down the 3. I'm going to put a plus, and I'm going to bring down the 4. And this is if we were adding 45 plus 60. I should have put that up there earlier. And we're going to leave it. We don't want to actually add it up. I know you can, and I know you're that smart. But just trust me, this is learning math that lets us do the cool math later, right? So we're not actually going to add them up. We're learning a different way to write them before they get added up. So instead of saying now 45 plus 60, I'm going to take this greatest common factor, which is 15, and I'm going to put it here. I'm going to put a parenthesis, 3, bring down that plus, 4. These two numbers, these two lines right here, this one and this one, are exactly the same. They just look different. One of the really neat things about math is we can do that. We can have terms, we can have phrases that are exactly the same, but they look different. Wait a minute. How can that be exactly the same? I'm not sure I believe you. I'm so glad you asked. Let's test it. So let's test it by multiplying these out. So what if I distributed, this is why it's called the distributive property. On the outside here, I have this 15. I'm going to distribute this 15 to the 3 and to the 4. When people make mistakes using the distributive property, they forget to multiply by everything inside the parenthesis. That's like when you go trick-or-treating and everyone that comes up gets candy, everyone in the parenthesis gets a 15. So the distributive property says, what is 15 times 3? 15 times 3, 15, 30, 45. Skip counting is a handy thing. We're going to say it's 45. Oh, well, that looks familiar. Just saying. I'm going to bring down that plus sign. Now I'm going to say 15 times 4. What's 15 times 4? 15, 30, 45, 60. Well, that looks familiar too. Look at that. They're exactly the same, 45 plus 60. So when you have two numbers and you want to rewrite it using the distributive property, how do you figure out how to do that? Easy. Upside down division. Pull out your greatest common factor here, give it a parenthesis, and put the leftovers. That's all it is. So distributive property works two different ways. We just saw how we took two numbers and broke it apart so that it was a number in a parenthesis so we could distribute it. But a lot of times it starts off just looking like that. It can start off looking at, like, say, 5 times 3 plus 6, right? It starts off looking like that. So now how do we get to the two big numbers? We're going to distribute the 5. We're going to take this number on the outside and we're going to multiply it by every number on the inside. Again, if you get it wrong, if you make a mistake, it's people forget this. I don't know why. I do it sometimes. It happens. I think our brain is like hardwired to forget. I don't know why. We can make up all the excuses we want. But really, we just have to remember that we're multiplying by everything inside the parenthesis. So what is 5 times 3? It is 15. Nice job. Bring down that plus sign. What is 5 times 6? It is 30. And so again, these are exactly the same. 5 times 3 plus 6 is the same thing as 15 plus 30. Okay? All right. We're going to try one more using upside down division to practice the other direction, and then we'll be done. All right, one more example. Again, doing some math that as we learn it lets us do more cooler math later, right? We're going to find out how can I write 120 plus 36 using the distributive property. All right, we're going to use our GCF. Start there. Does 2 go into both of those? You guys are so smart. You're like, yeah, they're even. We know 2 goes into both of those. Nice job. So let's see. 2 goes into 12 6 times, and we tack on the 0 there. 2 goes into 36. Well, it goes into 3 1 time, goes into 16 8 times. There we go. Can 2 come out again? Yeah, sure, you betcha. They're both even, so I can pull out a 2 again. What's 60 divided by 2? It is 30. Nice job. What is 18 divided by 2? It is 9. Good job. Can I pull out a 2 again? Oh, can't do it. 30 is even, but 9 is not. That's okay. Can I pull out a 3? That's the next prime number, right? And we can. 3 definitely goes into 30. How many times? 30 divided by 3 is 10. And 9 divided by 3 is 3. And we're done. Now they're not consecutive, one after the other, but we are done because there are no more factors that will go into 10 and 3. The factors of 3 are 1 and 3, that's it. And 1 we don't use, it doesn't change anything. And 3 does not go into 10, so we are done. So now we're going to write this using the distributive property. Easy peasy, I hear you saying, and I agree. We remember we're going to get the greatest common factor, and that's what's going to go on the outside. So what is 2 times 2 times 3? 2 times 2 is 4, times 3 is 12. Nice job. So underneath here, I'm going to put 12. I'm going to draw my parenthesis. And then I just bring down the leftover factors. These are the greatest common factors, and these are the other factors for these numbers. We just bring them straight down. We're going to bring down the 10. This plus sign all the way up there, we're going to bring it down, plus, and then we bring down this factor of 3. And now we have rewritten 120 plus 36. Using the distributive property, we have written it to 12 times 10 plus 3. Okay? Again, we're learning this math that lets us do cool math later, so we're going to be patient with that. Nice job. I do feel like we should check our work though, because it's always a good idea. You can use a calculator if you need to, but can you tell me please, what is 12 times 10? Oh, well, anything times 10, we're just going to put a 0 on the end, right? We're going to say 12 is, here's the 12, and then times 10, we're just adding a 0. That's multiplying by 10, so that's 120. To bring down my plus sign. What is 12 times 3? 12, 24, 36. I skip count for my 12s. Yep, it is 36. And look at that. All of these are exactly the same. You guys do really good work. I'm really proud of you. This is kind of a weird concept sometimes, and you did a great job paying attention and following along with me. I hope you did that on your paper before I did. I forgot to tell you to. I look forward to seeing you next time.